Welcome to DataViz with Class. I'm Caleb Class. Today we're going to talk about dplyr because sometimes your data needs a little work before you're ready to make beautiful visualizations. dplyr provides some great tools for this. If you haven't watched my previous video on basic data visualization using R and ggplot2, you might want to start with that. Today I'm going to talk about a few functions that can help get your data ready to make amazing graphs. The select function lets you choose which columns you want to keep. Filter lets you choose which rows to keep. Mutate lets you add new columns to your data set. And the best of all, group by and summarize let you do easy but useful summarizations of your data. Some of these functions take a little getting used to, but they give you a ton of power once you get the hang of it. So don't worry if you struggle a little at the beginning. Take it slow. Try to understand every line that I'm typing and what it does. And also check the link in the description to an amazing and free ebook that helped me learn how to use R back in the day. Don't give up, you can do it. Let's get started.
Let's start by opening up a new script and loading the tidyverse library. Tidyverse, and we remember that we run lines in a script using Control-Enter or Command-Enter. dplyr is another member of the tidyverse, just like ggplot, so you just need to load this one library. Next, let's load the dataset. I got this data about video game sales and critic reviews off of Data World. Full source and link in the episode description. One of the easiest ways to load data is to find it in your Files window. And I have it right here, so find it wherever you put it on your computer. Find it in your Files window, then you just need to click and then select Import Dataset. I'll go down here and click Import, and then you can see we have data about each game, the platform, sales data, and review data. And you can see there are some holes in the data. That's okay because we're just learning here. The data looks okay overall, so we're ready to go. If you go down to your console, you'll see that R ran this code to load the dataset. Let's go ahead and copy paste this into our script so we can have it for later. Control C, Control V. There you go. So we have video games is read CSV, and it read the CSV file of video games. And we just did that because if we want to leave and run our script again next week, we can just run this code. We can skip the other steps we did over here to load it in. If we just run this code, it'll load it in just like that. Another thing that helps if you want to leave and look at this code again next week is writing comments. So load the data. So we denote comments with this # or hashtag or whatever, Shift-3 on your keyboard, and they just let you write whatever notes you want to help yourself remember what you were doing. Let's start with the easiest dplyr command. Select chooses which columns to keep. We can choose the name and North American sales column with select video games, so the data set, and then which columns you want to keep. Name and NA sales, separated by commas. Control Enter. We can see we've got name, we've got NA sales. If I want to keep a range of columns instead, I will instead put a colon instead of a comma. Name : NA sales. And that keeps every column from name to NA sales. If I want to remove columns, I'll use a -sign. So select the data set, and then -name would keep every column except for name. It just removes the name column. So select chooses columns. I'm going to show you a second way to do the same thing, and that is called the pipe. Pipe looks like this. That's the vertical bar that's on the top right of your keyboard, and then the greater than symbol. There's also an older pipe that looks like this with %. They work exactly the same, almost exactly the same. You probably never notice the difference unless you're like a computer engineer, genius person, or whatever. So I'm going to use this one, but the other one is just fine too. So instead of putting video games inside of select, I'm going to yank it out. I'm going to put it out here by itself. I'm going to pipe it into the select function. and then say name NA sales. And this is just like how we selected name and NA sales here, except now we are doing it using the pipe instead. So we no longer put the data set in the select function. We pipe the data set into the select function, and then inside the select function, all we need to do is select which columns we want to select. The great thing about this is you can take the result of this function, we can pipe it into something else, do another function, and then we can keep going and do more and more things. We'll do some of that later. Finally, remember that any code we run like this, it's just going to show the result to your screen at the bottom. So just like this, we did select name and NA sales, it just showed the result, it didn't save anything at all. So if you actually want to save the result and use it in another step, you need to use the arrow. We could give our new object the name video game selected, put the little arrow, and then if we run that code, we can look over here in our environment. We can see where we used to have 17 columns. Now we have 2 columns because we just selected 2 columns. So now it has saved VG selected. We could even click on that. We can view it over here. And you can see Wii Sports sold, 41 million copies. We notice there are some missing values in this data set for some reason. These show up as NA. Maybe you'll just want to get rid of every row that has any missing or NA value. In that case, we can just use the NA omit function. I'll give the object a new name, VG filtered, because we're filtering out missing values. And I will take video games and pipe it into na.omit. We're using empty parentheses here because we're piping the data set into na.omit, so we don't actually have to type anything into it. If I hit that, we can see we have removed about 10,000 rows of the data set. 10,000 rows had a missing value, those got chopped out. So na.omit will just remove any row that has any missing values in it, but maybe we're okay with missing values in certain columns, but we don't want missing values in other columns. The filter function can help with that and other things too. Filter takes a logical expression you give it, and it keeps any row where that expression is true. What the heck's a logical expression? It's a statement that's true or false. Here's an example. 8's greater than 3. Right? The greater sign looks like a little alligator. This is true because the alligator wants to eat the big thing. If I switch to 8 is less than 3, the alligator doesn't want to eat the 3. That's disgusting, so this is false. So we can use these types of expressions to filter rows in our data set. Say I only want games with a critic score of 90 or above. I'll say VG high scores is video games, pipe it into a filter function. And what is the logical statement? It is critic score greater than 90? So maybe greater than 90, or we could also say greater than or equal to 90. We look at the high score video games, we can see we've only kept 90 or above. If we just want PlayStation games, we could say VG PlayStation is video games, and then filter platform is PlayStation. In this case, PlayStation is PS. Note that we use 2 equal signs when we want to say is something equal to something else. If you just put 1 equal sign, R will get confused. It'll think you're trying to do something else. So our logical statement is platform equal to PS. We put quotes around the PS because we're asking if it's equal to some character thing, some letters, not a number. If I wanted to put these things together and say they must be greater than 90, but they also must be a PlayStation game, you just put them together using this and symbol. Control Enter. Let's also change the name, VG both. And you can see there were only 28 PlayStation games that had critic scores greater than or equal to 90. There are other logical operators. You should try to get familiar with them, but also don't stress about it. Just try to get some practice. You can look them up if you forget. So let's go back to our data set. Let's say we really care about the critic score. So we don't want any missing values in the critic score, but we don't mind if other columns have missing values. We can filter for this using this is.na critic score. If we do that, we'll notice that we only kept the rows where the critic score is missing. That is not what we want. That is the opposite of what we want. And so if we get the opposite, we can flip the result using the not operator. So before we were saying only keep it if it is an A. Now we want to only keep it if it is not an A, and that is what we want. So we're going to run that, and we'll see that we kept 8,260 where the critic score was not an A. So now it's time for the best part. We're going to summarize the data using group by and summarize. This lets you ask simple or even complicated questions about your data, and it lets you get it ready for more advanced visualizations if you want. Let's start with group by. Let's say we want to group by platform. So we're going to start with this filtered data set that we just made. If we group by platform and we look at the data, we'll notice that we haven't actually changed anything. This is the same data set as before. The only difference is that we've marked that our groups are the platform. So we haven't really done anything. This is not going to be useful until we do something else with it. So a simple thing you could do is just pipe this result into the count function. So we've grouped by platform, and now we're counting. We're going to count how many rows there are for each platform. You can see in our data set, we've got 172 3DS games, 14 Dreamcast games, a bunch of other games. Count can only count. Summarize can do whatever sort of summary calculation you want. So I'll copy paste this part, and then instead of count, we are going to summarize. You can use a Z, or you could spell summarize with an S at the end if you're British. And let's say we want the sum of sales for games from each platform. Say sum of global sales. And better yet, we can give this new column of our summary data table a better name. We put that on the left. We can call it whatever we want. I'm going to call it total sales because that makes sense. I'm going to put an equal sign. So you can see that the left of the equal sign is just whatever name you want to give the column. The thing on the right is the actual summary calculation. So Control Enter. And we can see that dplyr has gone through all of the Nintendo 3DS games. It's added up their sales. It's gone through all the PlayStation games. It's added up their sales, and it's done it for all the platforms separately. We can add other columns as well with a comma. We can add the number of releases. We'll do that using the n function. So again, releases is just the title I'm giving the column. The n is the actual calculation. This is just like count, except it lets it put this into the summary table with everything else. Let's also calculate the average critic score for games on each platform. So we'll say critic average equals the mean critic score. Now you can see we've got 3 columns summarizing each video game platform in the dataset by the number of releases, the global sales, and the average critic score. Let's quickly copy paste and see what this looks like when we don't group. And it's just done these simple calculations over the whole data set. So group by lets us separate this out, calculate summary calculations for whatever groups we want to define. Next, let's talk about a simple one. Arrange lets you sort a data set based on a column, either alphabetically or high to low or low to high. So let's take the summary we've already done and let's arrange by total sales. By default, this is going to arrange low to high. And we can see the poor Sega Dreamcast at the bottom at 4.5. If we put DESC around total sales, that says descending. So now descending means high to low. So it's the same thing, just sort of the other way. Now we have PlayStation 2 in first place. Now let's plot it as a bar graph. It'll look better. We can send our summary table into ggplot using another pipe. So when we use a pipe, we do not need to say data equals data table or whatever we were doing before, because the thing that gets piped in is the data table. We do need our aesthetics function that tells us which columns become aesthetics of the graph. Let's make it simple. Let's just use X and Y axes and make a bar graph. So let's say we want platform on the X axis and total sales on the Y axis. We think a bar or a column graph is most appropriate. So I'm going to say plus geom_col to make that column graph. This bar graph looks okay. We've got heights according to the total sales, but remember we had it sorted high to low. We put it into ggplot, now it's alphabetical again. What happened? Why isn't it ordering the same? Maybe we could ask our favorite chatbot friend how to do this. The chatbot might tell you to reorder platform. Reorder platform using this reorder function, and then you can say what to reorder it by. And we'll do that just like we did our arrange function. So descending total sales. And now we can see that we have it high to low, just like we want it. We could also do plenty of formatting stuff to make the graph look much, much better, but we don't have time for that. Let's move on. What if we wanted to visualize both critic scores and sales summarized by platform? We can make a scatter plot for that. And now our aesthetics will be X is critic average, Y is total sales, and let's also say label equals platform to label each point by what platform it is. So we're making a scatter plot, so we need geom point, but we're also labeling the points, so we could use geom label. And now we're almost there. The issue here is that we've got a bunch of labels stacked on top of each other. Can't really read them all. We've got another package that can help with that. It's called the ggrepel package. This is a separate package from the tidyverse, so you could use install.packages ggrepel if you want to install it. But since I have it installed already, all I need to do is add this gggrepel package here and 2 colons. So this is just letting me use a package without having to use the library function and loading in the whole package. I'm just using one function from the library. So that is what this is. So this is from the gggrepel library. I want to use geom label repel. So I have barely changed anything, but now look how much better it's gotten. We can see our dots. Some of our little labels have been shifted away from the dots so we can see the dots and the labels aren't overlapping with each other. They look so much better and we barely did any work at all. And we can see that the Dreamcast was very low on sales, but the games were very well regarded by critics. See a very high critic average. The high selling platforms had plenty of good games, but also plenty of bad games. They brought the average down some. Again, this plot isn't very beautiful, but we can do beautiful another day. Today, we're just doing our job. We're doing it the best we can. Then we'll go home, we'll play Mario Kart with the kiddos, we'll give them a full lap head start, we'll get 12 bullet bills, then we'll beat them anyway. And what could be better than that? All right, last function, it's called mutate. You can use calculations to make new columns of your data table. So let's say we want to see which games were more popular in Japan versus North America or vice versa. We can pipe our data into the mutate function. We'll call our new column NAV/JP sales, and the calculation is NA sales minus JP sales. So these are 2 columns of our data set, North America sales minus Japanese sales. That gives us the difference between sales in the 2 regions. we are naming the result of this, the resulting column, NAVJP sales. So just like summarize, the calculation is on the right, the name of your new column is on the left. I'll also select, just to show you those columns, and we can see that Wii Sports, a few other Nintendo games, sold more in North America than in Japan. If we want to see which games are more popular in Japan, we can use arrange. So we will arrange by NAVJP sales. And we can see Dragon Quest, Monster Hunter, Animal Crossing, much more popular in Japan than in North America. A lot of the time we'll want to save this as an object so we can continue using that new column in our other calculations. Let's go ahead and do that. Say VG mutated. So let's end with something a little more complicated. We're going to do a grouped mutate. So remember we did group by summarize, now we're going to do group by mutate. Say I want to compare each game's critic score against the average critic score received by games from that platform. So we need a group by platform to be able to do that. So just like before, we're using group by platform, but now instead of summarize, we're going to mutate. So let's say the critic versus average score for each game is going to be the critic score for that game minus the mean critic score. So normally the mean would just be one number. It would just be the mean across the whole data set, the average critic score across the whole data set. In this case, the mean is going to be the mean for each platform because we use group by. So if we have a PlayStation game, we're going to take the PlayStation game's critic score minus the average PlayStation critic score. If we have a Wii game, we'll use the average Wii critic score. I'm going to add one more column just so you can see that. So the platform mean is just the mean critic score. We're just going to add that to every row. So I save this new data set. I arranged by this new column, high to low, and then I selected the relevant columns to make it easier to see. And there you have it, Super Mario Galaxy, the greatest game of all time, supported by at least 10 minutes of data analysis. Critic score 97, average score for Wii games was 63, so it was 34 points above average stupendous. You might argue that this is just because the Wii had a lot of bad games that brought the average down. Maybe. But the important thing is that we had some fun. We beat Bowser using data analysis. Did you have fun? Dunno, but I hope you learned something. Every little detail doesn't always sink in on the first try, so don't get discouraged if you find yourself stuck here or there. I get stuck here and there. Keep practice. I promise you will get the hang of it. Remember, there's a whole internet out there filled with answers when you get stuck. If there's somewhere you get stuck all the time and you'd like a tutorial about it, let me know in the comments.